Good morning, everyone. Today we begin with a big idea. Construction is not just about bricks, concrete, and steel. It's about how humans organize work to build something that did not exist before. This course is called Construction Project Management, or Construction Project Planning and Control, but it's really about how we turn vision into reality, on time, safely, and within budget. What is the largest construction project you have seen in real life? Why do you think construction projects often get delayed? If you had to choose one, is construction more about engineering or management? So, what is the takeaway here? Construction management exists because construction is complex, risky, and time-sensitive. Here's what we will accomplish in this module. We will define the industry, trace the history, analyze the sectors, and evaluate the future. If you're a student today, what do you want to gain from this course? Skills, career direction, or industry knowledge? When you hear the word construction, do you think of houses first, or bridges and highways? Here is a question for you folks. Please explain the difference between construction and manufacturing in one sentence. This slide is important because it explains why construction is called the economic backbone. Construction has high labor intensity. A major portion of cost is labor. High risk, but often low assets. Market instability, seasonal shifts, economic cycles, and constant exposure to uncertainty. Why do you think construction is called high risk? What happens to construction when interest rates increase? If 30 to 40% of costs are labor, what happens if productivity drops by 10%? Let us look at an example now. If a project is delayed by 2 months, it's not just time lost, it becomes money lost through extended equipment rental, extra supervision, extended insurance claims, and disputes. Construction is sometimes compared to manufacturing. But the reality is that construction operates in a completely different environment. Manufacturing occurs in a controlled setting, a factory, with stable conditions, standardized processes, and repeatable outputs. Construction, on the other hand, happens in the field, where conditions are variable and unpredictable. Every construction project is site-specific. Even two buildings that look similar on paper can behave differently depending on soil conditions, groundwater, access constraints, utilities, local regulations, and available labor. Construction also requires coordination of personnel who may not have worked together before, which introduces challenges in communication, workflow alignment, and accountability. Finally, construction projects are often custom-built and technically complex, involving unique designs and multiple specialized systems. This is why construction cannot be managed casually. It requires deliberate management to handle variability, maintain safety, control quality, and keep the project aligned with schedule and budget. In ancient times, large construction projects were typically led by what we refer to as the master builder. This individual was responsible for both the design and the execution of major structures. Projects were often built primarily with stone and relied on human labor, basic machines, and logistical planning that was impressive for the time. The master builder needed core competencies that are still relevant today: the ability to visualize structures in 3 dimensions, the ability to communicate and manage large groups of workers, and the ability to procure and transport large quantities of materials. While the technology was limited, the complexity of organizing work at scale was still enormous.
This era teaches us an important point. Construction has always required leadership and planning. The tools have changed, but the need for coordination and discipline has always been present.
As society evolved into the Middle Ages, construction priorities reflected the needs of the time. Much of construction focused on fortification and faith. Fortified structures, such as castles, were built for defense and security. At the same time, cathedrals and religious buildings were constructed as symbols of belief, power, and identity. This period highlights how construction is influenced by social drivers. Construction responds to what society values, whether that is defense, religion, commerce, or public infrastructure. Even today, we see the same concept. When society prioritizes transportation, we build highways and transit systems. When society prioritizes sustainability, we invest in green buildings and renewable energy infrastructure. Construction is never isolated. It is always connected to social needs, political priorities, and economic conditions. During the Renaissance, construction experienced a major transformation. Ideas and technologies expanded rapidly, and engineering and architecture began to develop as formal disciplines. One key shift during this period was the separation of the master-builder role into two distinct paths: the creator and the implementer. The creator represents the architect and engineer, those responsible for design, analysis, and planning. The implementer represents the builder, those responsible for construction execution and field delivery. This division increased specialization and improved technical advancement, but it also introduced new challenges. Coordination between design and construction became critical, and the need to manage communication between disciplines became more important than ever. This separation is a major reason why construction management emerged as a necessary function. Once work becomes divided among specialists, project success depends on integration. The Industrial Revolution brought transformative changes to construction. New materials such as iron and steel replaced many limitations of masonry and stone. These materials enabled taller buildings, longer spans, and more advanced structural systems. Steam power increased productivity and allowed machines to perform tasks that previously required massive manual labor. In addition to material advancements, logistics improved significantly. Transportation networks expanded, making it easier to move materials and equipment. Off-site manufacturing of components became more feasible, improving speed and reducing variability. This period marks the transition from traditional building methods to modern construction systems. It also introduces the concept of scaling construction through industrialized processes, an idea that continues today through modular construction, prefabrication, and advanced supply chain planning. In modern times, construction projects have become increasingly sophisticated. Buildings and infrastructure systems now involve complex structural design, advanced mechanical and electrical systems, tight schedules, and strict regulatory requirements. This level of complexity created the need for specialized project management and construction management roles. This slide highlights the tools that emerged to support modern construction delivery. Scheduling tools such as CPM and PERT became essential to plan activities, define critical paths, and control project timelines. Design tools such as CAD improved drafting accuracy and coordination. Integration tools such as BIM advanced collaboration, by connecting design information across disciplines and improving clash detection, sequencing, and visualization. Construction management developed as a profession because modern construction required structured control of scope, time, cost, quality, and risk. It became impossible for one person or one discipline to manage everything informally. The construction industry is typically divided into 4 major sectors: residential, commercial, industrial, and heavy highway. Each sector represents a different market type, and each has unique characteristics in terms of materials, complexity, risk, funding structure, and project delivery approach. Residential construction includes homes and housing developments and tends to use wood products and light framing systems. Commercial construction includes office buildings, schools, hospitals, and retail facilities, and often involves multiple building systems and specialty contractors. Industrial construction includes plants and facilities where performance and process systems are critical. Heavy highway construction includes infrastructure such as bridges, roads, tunnels, and rail systems, and is often publicly funded. Understanding these sectors is important because the management approach that works in one sector may not be suitable in another. Each sector has different drivers of success and failure. Residential construction typically uses relatively lightweight materials, such as wood framing and light-gauge steel. It is often characterized by low overhead, high competition, and tight margins. Because of the competitive nature, pricing pressure is strong, and contractors must manage cost carefully to remain profitable. Residential construction is also strongly influenced by economic conditions, especially interest rates. When financing becomes expensive, demand for housing can slow down. Residential construction also has a high sensitivity to supply chain fluctuations, labor availability, and seasonal effects. One key management aspect in residential construction is maintaining close working relationships with owners and clients, as many residential projects involve direct client engagement and expectations that can change quickly. Commercial construction involves a wide variety of materials, such as steel, concrete, glass, and complex architectural finishes. Commercial projects are typically more technically complicated than residential projects because they include multiple specialty systems and a large number of subcontractors. Commercial construction requires extensive knowledge of construction sequencing, coordination between trades, and effective communication. A commercial building is not just a structure. It is a collection of systems that must operate together, including HVAC, plumbing, electrical, fire protection, vertical transportation, and building envelope performance. The construction manager in commercial projects plays a major role in coordination, scheduling, and conflict resolution. Success depends heavily on planning, trade management, and maintaining project momentum. Industrial construction includes facilities such as petroleum refineries, power plants, and manufacturing facilities. These projects are performance-driven, meaning the facility must meet strict operational requirements. Industrial projects are highly specialized and often schedule-driven because delays can have major financial consequences. Heavy highway construction focuses on public infrastructure, such as roads and bridges. These projects often involve heavy equipment, significant earthwork, traffic control, and strict compliance with government standards. Heavy civil projects are frequently publicly funded and may involve complex stakeholder environments, including agencies, communities, and environmental oversight. Both industrial and heavy civil projects require disciplined management due to high risk, high complexity,
and high public or operational impact.
This slide explains why specialized construction managers are needed today. The construction environment has evolved beyond the capacity of a single master builder. Project size has increased, organizations have become larger, and coordination requirements have expanded. Technical complexity has increased due to advanced systems and interdependencies between disciplines. Government regulations have increased, requiring compliance, documentation, and oversight. Schedules have also become more aggressive, forcing teams to deliver faster while still maintaining safety and quality. This combination of complexity, regulation, and schedule pressure creates an environment where professional management is not optional. Construction managers provide the structure needed to coordinate stakeholders, control risk, manage resources, and maintain performance across all project constraints. The future of construction is shaped by innovation and transformation. New tools such as robotics, drones, and virtual reality are improving productivity and safety. New methods such as off-site manufacturing and modular construction are changing how projects are delivered. Public-private partnerships are becoming more common as funding models evolve. Professional certifications and formal training are also becoming more important, raising the standard of professionalism across the industry. This slide emphasizes that the future belongs to educated construction professionals. The industry's image and performance improve when construction managers bring technical understanding, ethical leadership, and strong communication into the field. Construction is no longer just a trade-driven environment. It is becoming a data-driven and technology-enabled profession.